Oh, sorry. Can you hear me now? Not audible. I think everybody will be able to hear me now. Yes, Ankit says yes. Okay, cool. All right. So, how was your contest today? Like, we had what? How many? 7 problems today. 6 actually. Like, we had F1 and F2. So, how many problems were you all able to solve today? But echo is there. Is that for everyone? Or is everyone able to hear some echo? Contest for you. You're great for solve 5. But echo is there. Echo, I think Ankit, you are only getting the echo. Nobody else is getting any echo. Only I mean in UNCP. That's okay then. A, B, C, E, F1. Okay. I see C had D problem. D had less submissions. Actually, like D was actually very heavy implementation. Okay. A, B, C, D, F1. Okay. A, B, C, F1. A, B, C, and F1 were easy. The only good questions were like D and E. And F2 is also like segmentary. B problem is max and second max. Now, yes, exactly. Okay, cool. Okay, should we start now? I'll be solving all the problems. Let me just update the thumbnail of today's one. Okay, so I'll be solving all the problems today. So let me just write like all problems, or at least in the title. Okay, cool. Let's start now. So I'll be starting with problem A first, and we'll go in order only as usual. So let's go for problem A now. C was same as minimum deletions to make array beautiful on lead code. Okay. Okay. Anyways, let's start with problem A. I'll try to end the stream in like 45 minutes today. We'll go a little faster than usual. So problem A says that Wasir decided to go to the grocery store. He found in his wallet A coins of 1 bubble and B coins of 2 bubble. He does not know yet the total cost of all goods, so help him find out S. The minimum positive integer amount of money he cannot pay without change or pay all at using only his coins. So basically, what we have is he has A coins of amount 1 and B coins of amount 2. And we need to find the minimum amount which this person cannot pay. Okay, so let's take the very first example. Let's say we have one coin of 1 rupee and one coin of 2. Okay, now if you have to pay amount 1, then you can just use this one coin. If you have to pay amount 2, then you can just use this coin. And if you have to pay amount 3, then you can use both these coins and the sum will become 3. But there is no way you can pay an amount of 4. Okay, so the answer for this one is going to be 4. Okay, let's say, okay, 0.21. Okay, let's take the next input. Let's say we had 4 ones and 0 twos. Okay, now since we have 4 ones, we know that we'll be able to pay amounts of 1, 2, 3, and 4, but we won't be able to pay amount 5 because there are no coins. Now let's take 0, 2. If we have 0 coins of amount 1 and 2 coins of amount 2. Now, can you pay amount 1? If you have to pay amount 1, there is no way you can do that because the least value coin you have is of 2. So the answer for this one is 1. Okay, so let's take the very last case now. Okay, so the last case says that we have 2314 coins of amount 1 and 2374 coins of amount 2. Okay, now any amount till 2314 will be paid using 1 coins only. Let's assume that. Okay, now how do we pay 2315? We can use 2313 coins of amount 1 and 1 coin of amount 2. This will have 2, this will be 2313, and the total size will be 2315. Okay, similarly, if we have to pay 2316, okay, now we can use all these 2314 coins, and one is this one. And similarly, if you go you will see that the amount which you won't be able to pay will be the total amount of these coins plus 1. So what is the total amount of these coins? The total amount of these coins is actually 2374 what times 2 plus 2314. So this is this, and summation of these give us 7062. And if you see, the answer for this one is 7063, because till 7062 you will be able to pay by some configuration of these coins, but after that you won't be able to pay because you don't have any coins. Okay, so the logic becomes that if you have even at least one 1 rupee coin, then your answer is the total amount plus 1. If you do not have any 1 rupee coin, then your answer becomes 1. Okay, so let me just show you my code for this one, and I'm assuming that everybody was able to do this one. So what I'm actually doing is, if a is equals to 0, that means the number of coins of amount 1 is equals to 0, then just print 1, else print a plus 2b plus 1. A is the total amount of coins of size 1, 2b is the total amount of coins of size b, and this is plus 1. Okay, so I believe this is clear to everyone now, and let's move on to problem B now. Okay, not so long while Vlad has had a birthday for which he had presented with a package of candies. There were n types of candies. There are AI candies of type A. I. Okay. So basically, what we have is we have n different types of candies, and of every ith type we have AI number of candies. Deepak says, can you please tell the topic and concept which should be done to be able to solve problem B, because it had been 2 months. I'm still not. Okay, I'll explain to problem B properly. Okay, so we have n candies, and every candy of every type of candy we have AI amounts. Okay, so we have A1, A2 till AN. Okay, now Lad decided to eat exactly one candy every time, choosing any of the candies of a type that is currently the most frequent. If there are several such types, he can choose any of them. Okay, to get the maximum pleasure from eating, Lad does not want to eat 2 candies of the same type in a row. Help him figure out if he can eat all the candies without eating 2 identical candies in a row. Okay, so let's take the very first test case. Okay, in the very first test case, we have 2 different kind of candies, and the first candy has an amount of 2, and the second candy has its frequency as 3. Now, since Vlad only eats candy with the highest number, so he eats this one. Your new array becomes 2, 2. Now he can eat any of these candies because both of them have a frequency of 2. So let's say he eats the first one. Now it becomes 1, 2. Then he eats this one because this is highest, so it becomes 1, 1. Now let's say again he eats the very first one because he can eat any one. So it becomes what? 0, 1, and then it will become 0, 0. And since he's able to eat all the candies, the answer for this one is here. Okay, let's take the next test case now. In the next test case, we have only one candy, okay, and the size of that is 2. So first he's going to eat one candy of this type and the size becomes 1. But now, since there are no other candies and the highest frequency of this one is this only, we'll again have to eat this candy, which is not allowed, because it is given that Vallard does not want to eat 2 candies of the same type in a row. Okay, so the answer for this one becomes no. Let's take the third test case. Okay, this one is a nice test case. Okay, let's take 1, 6, 2, 4, and 3. Now, since this 6 is the highest, he will have to eat one candy from this type, and this value will now become 5. So the new array becomes 1, 5, 2, 4, and 3. Okay, now again, if you see, this is the highest number in this one, so he'll have to eat this candy again. Okay, and since again he has to eat this candy, these are 2 same candies in a row, and therefore the answer for this one becomes no. Okay, now what if this value was already 5? What if this value was already 5? Okay, if this value was already 5, first he would eat this one only and it will become 4. Okay, then we have 2 4s now. Since he ate this one in the last turn, he will eat this one now, so this becomes 3. Okay. Now, since this is the highest, he'll eat this one and this will become 3 again. Now he has 3 options, either this one, or this one. Since he ate this one in the last one, he needs to eat either this one or this one. So let's say he ate this one. Then he eats this one, then he eats this one. Now you have 4 twos. You can eat any one of these except this one because this candy was eaten in the last turn. So take any of these indexes and say that we ate that one. So let's say this was eaten. Now make these also 1, 1, 1. And now this candy was eaten in the last time. Okay. So take any other candy except this one. So let's say we took this one. This was 0. And now take this candy. This becomes 0. Take this one. This becomes 0. Take this one. This becomes 0. Take this one. This becomes 0. Okay. So what do we get from this? Let's take this test case. Okay. Because this actually tells us the logic. Let's say, or let's take a smaller one. Let's say we have one candy of size 1. We have one candy of size 99 and one candy of size 100. Okay. Now, can these two candies toggle between each other and complete? Yes, we can do that. First take this candy, then take this candy, then take this candy, and so on. Because when you take this candy, it becomes 99, 99. Then take this one, it becomes 98, 99. Then take this one, it becomes 98, 98, and so on. Okay, let's say the first value was some value x. There will come a point when this value or this value will become equal to this x. Now, instead of having 2 same values, you have 3 same values. So you can keep on doing the same thing. So essentially what you need to see is that in the very first turn, we are taking the candy with the highest amount. Okay, so whatever that highest amount is, let's say the highest amount was in the beginning. Okay, the highest amount was x max. Okay, and the second highest, okay, let's say we have 2 amounts, which is highest and the other amount is second highest. Okay, now we know that in the very first turn we'll have to eat this highest candy. Okay, so let's say we ate this highest candy and this now becomes highest candy minus 1. Okay, now we cannot eat this candy anymore, so we will have to eat this one only. But we can only eat this one if second highest, let's say sh, is greater than or equal to highest minus 1, which actually says that highest minus second highest should be less than equals to 1. If this condition satisfies, then we will be able to toggle between these two candies and make these 0. Okay, and in between these there will be multiple elements. Let's say any other element had a frequency of x. So whenever this highest or second highest becomes equal to x, we'll actually start toggling between 3 elements instead of 2, and so on. Okay, so this is the only condition that you had to check. If this is true, then the answer is yes, otherwise the answer is no, except one case when the size, there is only one candy. If there is only one candy, then you need to see if that element is equal to 1. If it is equal to 1, that means just eat that candy for once and you're done with the entire array. Otherwise, if the value is 2, then you'll eat one candy of this type in the very first turn, but now in the next turn you cannot eat this candy anymore, but there is only this candy left. So the answer for that one will be no. Okay, so let me show you my code. Okay, so this is the code. What I did was I just scanned the complete array, then sorted the complete array, and then checked if the size of the array is equals to 1. Then I need to check if that value is equals to 1. If it is equals to 1, I print yes, otherwise I print no. Now, if the size of the array is greater than 1, I need to see if my highest value, which is the last value in the array, because we have sorted the complete array, if the highest value minus second highest value is less than equals to 1, then my answer is yes, otherwise my answer is no. Okay, is this clear to everyone? Let me read the chart. There okay, there is a lot of chart. Okay, okay, till 50 it's great. Okay. Okay, actually, okay, maybe it will require me more 502. Okay, first I thought of using multiset in problem B. Yeah, you could have used multiset as well, not an issue, but like using an array is pretty easy for this one. Okay, cool. I believe everybody is clear with problem B as well. So we can move on to problem C. Okay, cool. Let's move on to problem C. Okay. Now, string A is equal. Okay, so we are given a string A and it is called even if it consists of a concatenation of strings of length 2 consisting of same characters. Okay. In other words, a string A is even if two conditions are satisfied at the very same time. Its length is n is even. Okay. For all odd I, ai is equals to ai plus 1. So n is even and ai should be equals to a of I plus 1 for all odd I. Okay. So basically, let's take this one only AABB. Now, if we have AABB, length of this string is even and odd indexes, which is this one and this one, this is equals to this A, this B is equals to this B. Therefore, this string is called what? Beautiful or what? Even. This is an even string. Okay. Now, whereas if you take some other string, let's say what? AAA. The length of this string is not even, therefore this is not a even string. And let's take ABAB. In this also, the length of string is even, but the very first character is not equal to the second character, therefore it is not an even string. Now, let's take some test cases. Let's take the very first test case only. So we have A, B, B, D, A, D, D. Okay, and what? How many C's? 3 C's. Now, this A and this A are same. Okay, this B and B are same. What about this D? This D can match with this D. So let's say we deleted these two elements. Okay, now this C is as same as this C, and let's say we deleted the last C as well. So we deleted 3 elements, and the new string now becomes AA, BB, DD, C. Okay, so by deleting 3 elements, we can get this string, and we need to get the largest string possible. Okay. Deepak Joshi says, I want to clearly that. Can you please, what should be done to be able to solve B of Div-2 like topic and all? Just practice more problems. Okay, of like difficulty of problem B. Okay, so how to do this one now? Let's take one other test case. Let's say we had which one? A third test case. We had A, B, B, and B. Now, the very first A says that I can either like V2 can be a pair. This A will say that I can actually pair with this one. So delete this B. Okay. Then this B says that I can be paired with this one and delete this B. So by deleting 2 elements, this one and this one, you had a string of A, B, B. Okay. Now, how to solve this problem? Okay. Let's take this test case only. Now, in this one, there are actually 2 answers. The one answer is that we can actually take 4 times A and then BB. What? Yeah, okay. And the other answer is that we can actually have 2 times A and then 4 times B. That we deleted this A and we paired this B with this one. Please adjust the cam. Some content is going out of view area. I don't think so. Is that so? I'm trying to make sure that it stays in this half only. Okay. I want to clear. Okay, what if there are similar elements more than 4 in between the deletion? Okay, I'll explain that. More than 2. Okay, okay, cool. Now, how to do this? Basically, what you can do is that whenever you are at a certain index, okay, let's say this is the complete string. Okay, and when you are at a certain index, let's say you had x at this particular index, you will see when was the last time we had an x. Let's say we had an x here. So we'll try to pair this x with this one. So these two will add 2 to the string and see the answer till this index. So answer till this index plus 2 will be the answer of this one. Either this or we can actually remove this x and see what is the answer till this index. So I'll explain this again. Let's say a complete array was this. Okay. And let's say at a certain ith index, you had x. Okay. Or let's say at a certain, yeah, ith only. Okay. And let's say this x was also present somewhere at this index, and let's say this index is last. Now my answer is actually going to be, so answer for I is actually going to be answer of last minus 1 plus 2. That take the array till this point, find out the answer of this particular array, and then add 2 for this x and this x, and delete all the elements in the middle. Or my answer will be answer of I minus 2, which means that remove this index, delete this index, and find out the answer till this index. And that's it. Is this clear to everyone? I'll even show you the code also. Should I do a dry run for the very first test case? Okay, let's do a dry run for the very first test case. So the very first test case is A, B, B, C, A, B, D, and then 3 times C. Okay. Now, this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Do dry run for the last one. Okay, let's do it for, I don't think like last one is a good example. Okay, I'll do it for this one only. Okay, so what is answer 0? My answer 0 is actually 0 only. Okay, because this cannot make any string. Now let's come on to answer 1. This answer 1 says that I'm equal to A, and the very last index, okay, where I had A was this one. So 2 plus answer of the array before this one, which is nothing. Okay, so the answer 1 will become equal to 1. Now, what about answer 2? Since we do not have any B before this, so no addition of 2, okay, but answer of like this minus 1. So basically 2 only, which is the previous answer. Coming on to 3, answer of 3 will actually be, I have a B here. When was the last time I had a B? It was index 2. So add 2 plus answer of the last index minus 1, which is this one. Answer of 1 was 2. So 2 plus 2. Now coming on to answer of 4. When you come on to answer of 4, since this D came for the very first time, we cannot pair this with anything. So we'll have to leave this D. So answer of 3 will be the answer of this one, which is 4. Now answer of 5. Answer of 5 is this B. This B says, when was the last time, when was the last time you had a A? It was at index 1. So find out, so add 2 plus the answer of last minus 1, which is this index. Answer of 0 is 0, so 2 plus 0. Now answer of 6. Answer of 6 is this B. So this B says, when was the last time you had a B? It was at index 3. So add 2 plus answer of 3 minus 1, which is 2. So answer of 2 is 2, so 2. Then answer of 7. Okay. This 7 says, I have D at index 7. When was the last time you saw a D? It was at index 4. So add 2. Okay. Add 2 for this D. And then find out the answer before this array, which is answer of 3, which is this one, which is 2 plus 2, 4. So 2 plus 4. And similarly, you can go on. Mohit says, sir, I cannot understand. Can you please explain the addition? I'm stuck on the question for... Okay. I'll just explain this again, if that is the case. Okay. What I'll do is, I'll also open up my code. Okay. Okay. So basically, or let me just remove my code and explain this test case again. okay, let me write down the test case again. So test case was what? We had what? A, A, B, B, D, A, B, D, C, and C. Okay. And let's say we keep a track of when was the last time we had an A, when was the last time we had a B, when was the last time we had a C, and when was the last time we had a D. And okay, so this is index 0. This is index 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now, for the very first input, we can say that, okay, I'm writing my answers here. The answer will be 0 because it is an odd length string and there's only one character. But we can say that A is present at 0th index. Now, when we again come on to this A, we'll say that when was the last time we had an A? The last time we had an A was at index 0. Since we had an A before also, add 2, okay, my current answer will be 2 plus answer of this index before this index. So before this index we have nothing, so this 2 only. So write 2 here. Then we come on to this B. This B asks, did we have any B before this B? Since there is nothing present here, that means there was no B before this one. Therefore, we'll have to leave this B and the answer will be the previous index's answer only. So answer is 2. Now, but we know that we had a B at index 2. Now, coming on to this B. This B says that, did we have a B before this B? Yes, we had a B at index 2. So add 2 plus answer of this index minus 1, which is this. So 2 plus 2 is 4. Or the answer could have been, we could have entirely left this index and found out the answer till this index only. So the answer before this one, which is 2 only. Now since this 2 plus 2 is higher, therefore the answer for this index becomes 4. Okay. Then let's move to the next index, which is this D. This D will ask, did we have a D before myself? No, since there is nothing present here, therefore we didn't have any D before this one. Therefore, we cannot pair this D with anything. Therefore, the only option that we have left is that we can remove this D entirely and find out the answer till this index only, which is okay, which is this 4. Therefore, the answer for this one will become 4. Okay. Then, but we did get to know that we had a D at index 4. So let's write 4 here. Now coming on to the next index, which is A. Okay. This A will ask, did we have a A before this? Okay, this has to. Okay. Yes, we had a A at index 1. So add 2 to the answer plus answer of index 1 minus 1, which is like at this index only. So 0 has 0, so 2 plus 0. Or we could have entirely left this A and find out the answer till this array only, which was 4. So let's write 4 here. Since the maximum out of 2 and 4 is 4, so answer for this is 4. Coming on to the next index again. Okay, update this index as 5 now. Now we have a B. When we have a B, we'll ask, do we have a B before this one? Yes, we had a B at index 2. Since we had a B before this one, so answer will be 2 plus answer of this index minus 1, which is answer of 2 minus 1, answer of first index, which is 2, so 2 plus 2. Or we could have entirely left this index and find out the answer till this index, okay, which is 4. Since these two are equal, so the answer for this index will become 4 only. Now coming on to this D will, okay, we need to update this index. This is 6. This D will ask, did we have any D before my... Yes, we had a D at index 4. So add 2 to the answer plus answer of 4 minus 1. Answer of 3 is 4. So 4. Or let's keep this D out of the string and find out the answer till this index only, which is this 4. So 4 only. Since 2 plus 4 is 6, which is greater than 4, for the answer for this one is 6. And so on, we can calculate. Now, let me show my code very quickly to make you understand what I'm actually doing. Okay, so basically what I was doing is, so first I made an answer array till n plus 1. So basically I'm trying to keep one base indexing. Okay, so I have an array, answer array till n plus 1th index, and everything is initially 0. Then I make last 26. This is to maintain, to see which character was present previously. Okay, so this last actually tells me the last index at which I had a particular character. So, and the size of this one is 26 because there are 26 different characters. Okay, and I'm hard coding everything initially as equals to 0. Now I iterate the complete string and see, did we have the character s of I minus 1 previously? If we had, it will not be equal to 0. It will have the index. Okay, since it is equals to 0, therefore we didn't have, therefore the answer is previous only, answer of I comma answer of I minus 1. If we had this character before also, then the answer is 2 plus answer of last index minus 1. Okay, and then again we can just take, maybe the previous answer was bigger. If it was bigger, then just calculate, take that one, and then we update the last index, and that's it. Is this clear to everyone? Are you going to solve D? Yes, I'll be solving D. Okay, I hope problem C is clear to everyone now. C is also done with multiset easily. Is that so? I don't think so. Like you can do the C using multiset. No, not clear. Okay. Is okay. How do I explain this? So basically, what I'm actually doing is the code not clear, or the logic also not clear? Okay, so basically, what I'm actually doing is, for every index, whenever I'm at any particular index, I see, did I have this character previously as well? If I had it previously, then take 2 for these two characters and then find out the answer for the before I had till this index. Okay, so I'll again do that. So if this was my complete string, okay, and let's say I had x here and x here. So when I'm calculating for this index, let's say this is ith index, this is last index. My answer of I is actually going to be 2 plus answer of last minus 1. This is essentially that, take this x and this x, remove all the elements in the middle, and then find out the answer of the array before this one. Okay, or I can entirely remove this x last. This is I can remove this x from this string and find out the answer till this index only. So which is answer of I minus 1. This is what I'm doing. So answer of I minus 1, I'm actually doing it here, and 2 plus answer of last minus 1 is this thing. And then I'm just updating the last character for everything. What will you do for the 0th index as in the first example? Okay, so basically to do that, what I did was I implemented my code with one based indexing. Okay, through that you don't really have to take care of the 0th index. Okay, so I hope problem C is also clear to everyone now, and we can move forward to problem D, which is a good problem, which is actually a very heavy implementation. I myself had a lot of difficulty in implementing. Okay, cool. Let's move on to problem D now. I don't see many likes to the stream. I only see 28 likes, and there are 51 people watching. So kindly like the stream at least. Okay, understood, bhaiya. Thank you. Okay, cool. Okay, so problem D is maximum product strikes back. Okay, you're given an array A consisting of n integers. For each I, the following inequality is true. Okay, so we have what? N integers. Okay, and every AI is less than equals to 2 and greater than equals to minus 2. Okay, now you can remove any number of elements from the beginning of the array and any number of elements from the end of the array. So if this is the complete array, you can remove some elements from the starting and you can remove some elements from the end. Okay, now you need to answer the question, how many elements should be removed from the beginning of the array and how many elements should be removed from the end of the array, so that the result will be any array whose product of elements is maximum. Okay, so you need to find a subarray basically. Let's say this subarray such that the product of this subarray is maximum. If there's more than one way to get any answer with the maximum product of elements on it, you're allowed to output any of them. Okay. The product of elements of an empty array should be assumed to be 1. Okay, cool. Now, okay, so how do we do this? The very first thing to notice in this is that AI can be equal to 2 also. So if all the AIs are equals to 2 and the size of the array is, let's say, 2 into 10 to the power 5, then the total product will be 2 to the power 2 times 10 to the power 5, which is very large, and you cannot store this in a variable. Okay, so you cannot have any general algorithm run over this. You need to find the count of all the 2's. Okay, how to do this now? Okay, let's see what all things do we know. I'll remove my screen and try to explain like what all things do we know. Let's say this is the complete array. Okay, we know that whatever our answer array will be, there won't be any zeros in this one. Let's say this is the answer array. So we know that the count of zeros in this array will be 0. Because if there's any 0 present in this array, then the total product of this array becomes 0. So count of 0 will be 0. Now, what about negative values? How should I write? Count of negative values. Count of negative values and this array should be even. Okay. Because if it is even, then every negative value will be equated with the other negative values and the total product of these negative values will be positive. Okay. So that's it. And count of 2's should be maximum. The number of 2's you have in this subarray should be maximum. Okay. Wherever you get these 3 conditions satisfied, you have the answer. Okay. So how to do this? To do this, what I'll actually do is, let's say I had this array and I was as iterating this array, and let's say I was at this certain index. Okay. What I'll do is, I'll say that, let me assume that this is my right side. Okay. So I'll remove elements all the after this and now try to see what is the value of L. Okay. How do I do that? I can easily store when was the last 0 that I had. Okay, so let's say we had a 0 before this. Okay, now I need to see, okay, so this is the array which I'm left with, and this condition is satisfied, that count of zeros in this array is 0. Now I need to see what is the count of negative elements in this one. Okay, if it is even, no problem. If it is odd, remove those elements as well. So let's say we remove these much elements as well because there was some negative element present here. Now my final array is this one. Now I'll check the number of times I have 2 in this array. If it is maximum number of times I have 2, then I can just say that this might be an answer, or else I can move forward. Okay. So how to do this? Basically, okay, I think I'll have to show my code as well now. Or let me try to do it using this only. Okay. So when I have my array and whenever I encounter a 0, if I encounter a 0, I know that I'll be removing all the elements after this, but there is no element that I can take before this as well, because my very first element which I need to take is 0. Therefore, you have to do nothing. Okay, and you can just like remove all the variables. Okay, just make a count of 0 still here 0, count of negative value still here 0, and all that. Okay, then what if the value you get, okay, is something other than 0? Then what you need to do is find out when you had the last 0, find out how many negative values you had till this one. If it is even, perfect. If it is odd, remove the element, remove one negative element, and then see the count of 2's. Okay, now I'll show you my code on how to implement this. Okay, a pretty lengthy implementation. I found maximum prefix and suffix product, resetting product, I'm reaching 0, but got wrong answer on second case. What's wrong with this? maximum prefix and suffix. You are actually not looking at the negative values. Okay, so this is the code that I wrote, a little lengthier code. So let me just try to explain like what I'm doing. Now, what all things did I had to do? If I had count, okay, one more thing I'm actually left with. Okay, so this was my complete array. Okay, and I am currently at this index. So which means that I've removed all the elements after this. Now I'm already keeping track when was the last zero I had. Okay, so let's say my zero, okay, was at last zero. Let's say I had a variable with the name last zero and it was this index. Okay, what I'll do is I'll remove all the elements before this one. Okay, now I'll already have a prefix array of count 1. Okay, so what I'll do is, let's say this is I. So what I'll do is count 1 of I minus count 1 of last 0. This will tell me all the ones I had here. Okay, and similarly for 2 also I'll have the same thing. Count 2 of I minus count 2 of last 0. This will tell me all the 2's I had in this string. Okay, now what is left? Now you just need to find out when was the last negative you had. If you know that last negative also, you can just remove the values till that point. This last 0 will become last negative then, because you need to remove either the 0 or the last negative if the number of negative elements between these is greater than, like, not even. Okay, so if I show my code now, so what I'm actually doing is I am scanning. Okay, I have my vector v of size n plus 1. Again, I'm doing everything in 0 based indexing, so that whenever I have to do like subtract some values, I don't really need to see that if it's a 0 index or not. Okay, and I have count 1 and count 2. So I'm scanning every index, okay, every value, and then I'm just checking if it is equals to 1 or minus 1, then I increment my count 1. If it is equals to 2 or minus 2, then I increment my count 2. Okay, and I'm making prefix arrays of this count 2 and count 1. Okay, now these are some variables that I need to have. This is total negatives I have. Okay, last 0 and last negative. Okay, then maximum number of 2's I have till now and current 2's. Okay, so what I'm actually doing, I'm iterating the complete string. Okay, so let's say I'm at certain index I. Okay, if it is equals to 0, then I just need to reset all my values. My last 0 will become equal to I because I have 0 at this index. Total negatives will be 0, last negative will be 0, and current 2 will be equals to 0 and continue. Now, what if I had a negative value? Okay, if I had a negative value, total number of negatives in this section will become increased by 1. If it is equals to minus 2, then my current 2's will be incremented. Now I'll see what is the count of total negative. If it is even, then go in this one. If it is odd, then go in this one. Now, if it is even, I'll see if my count of current 2's is greater than max. If it is greater than max, I can actually have this as an answer. Okay. If it is an odd number, what I need to do is I need to find out what was the point where I had my last value as negative, or the very first value as negative in this set. Okay. Now, if it is equals to 0, which is not possible. Okay. This is not possible. Okay. What I'll do is count 2 of I. So basically now all the 2's I have till ith index minus all the index 2's I had till last negative index. I need to remove, like, subtract this count in order to find what all 2's I have in this section. If this count of 2 is greater than maximum number of 2's I have till now, then I can say that this is my answer. And I've done the exact same thing for positive numbers as well. The only difference is this total negative plus gets incremented for this one. So I could have actually removed this for complete else and wrote this for this one as well. How did you get the intuition for C that greedy won't work but DP would? This is actually greedy only, I would say, not a DP. like somewhat greedy only. Okay, a little lengthier problem in terms of implementation, but an easy problem again. Though I don't really like these problems myself because the implementation takes a lot of time. Okay, cool. I think we can move forward to problem E now. If you are in any case like having still having difficulty in understanding this problem, just go to my code in my submissions and try to understand this code. Okay, that's it. Okay, let's move on to problem E now. Okay, you're given a binary matrix A of size n and n. Rows are numbered from top to bottom from 1 to n. Columns are numbered from left to right from 1 to n. The element located at the intersection of row I and column j is called A of ij. Consider a set of 4 operations. So what you have is, you have a matrix, binary matrix. Binary matrix means every element in this is either 0 or 1. Okay. Now you can do 4 types of operation. The first operation says that cyclically shift all rows up. That means if this is 1, 2, 3, 4, 5 and let's say 6, every row will uh, move on to the row above this. So basically it will become 2, 3, 4, 5, 6 and 1. Row 2 will become the very first row 3 will become the second row 4 will become the third row and so on, and row 1 will become the sixth row. Okay, so this is cyclically move all rows up. You have the same operation for the down as well. You can move all the rows to the down as well. Then the next says that cyclically shift all columns to the left. So you can do this for the columns as well, that you can shift all the columns to the left, or you can shift all the columns to the right. Okay, so now these are the 4 kinds of operations you have. Okay, now I need to, like, there is something that you need to know to solve this problem, which is that whenever you have these 4 types of operations, okay, and let's say you have a certain value here, using these 4 operations you can actually move this x to any of the other places as well. Okay, so let's say we had to move this x to this index. What you had to do was cyclically shift all the columns to the right this number of times and then move all the rows one time and so on. So basically you can actually move any element to any other place. That is what these 4 operations mean. Now you can perform any arbitrary number of operations on the matrix. The operations can be performed in any order. After that you can perform any arbitrary number of XOR operations. Select any element aij and assign it with the value of ai XOR 1. So if you have aij, it will become aij XOR 1. Okay, cool. So basically what it is saying is that 0 will become 1 and 1 will become 0. Okay, now each application of the XOR operation costs 1 burl. Note that 4 operation shifts are free. So shifting operations are free, but this XOR has a cost of 1. Okay, output the minimum number of bubbles you would have to pay to make the A matrix unitary. Unitary matrix is a matrix with ones on the main diagonal and the rest of the elements are 0. So basically what it is trying to say is that, okay, I'll remove my screen now. It is saying that if this is the matrix, okay, let's say this is a matrix of size 4 only. Okay, you need to have the final matrix should be something like this. Okay, now I've already told you that you can actually rotate this array in any way. Okay, using the cyclics, this array can actually be converted to this also, that we have 1 0 here. Okay, and this 0 would have come, this 1 would have come here. Sorry, not here actually. This 0 would have come like anything above this. Okay, but this would have also moved. Okay, so basically what I am trying to say is that, what if I fix this element, this element, this element, this element as 1, and try to make all the other elements as 0. Okay, now how will I do that? I need to find out what all values do I have at the diagonal, okay, and what all values do I have at any other places. Okay, so let's take the very first test case only. I have 0 1 0 0 1 1 1 0 0. Okay, now if I move all these rows one column one row down, then this becomes 1 0 0 0 1 0 and 0 1 1. Okay, these form a diagonal and we need to remove this one. So the answer for this is 1, that you need to make one operation for this one. Okay, and this diagonal is the answer. Okay, now let's see this one, like what is happening. This element could have moved here or here as well. This element could have moved like here, then it could have moved here, and so on. Okay, so what you need to see is that, okay, how do I explain this? Basically what you need to do is you need to see what all values are similar to this one. Okay, so which is I comma n minus 1 minus j. Okay, we can identify this value as I comma n minus 1 comma j, and which all values have the same values, they will all come on the diagonal. What I mean by this is that, how do I explain this? Yeah, okay, cool. So let's say this was the matrix that I had. Okay, again 4 4 only, let's say, and let's take two elements. Let's take one element here and one element here. This element is present at 3 comma 1, so x is present at 3 comma 1 and y is present at 4 comma 3. Whenever I move all these elements one row column after, the new indexes will become 3 comma 2 and what, 4 comma. Okay, and if I move these elements one column up, then they, okay, so this is down. Okay, no, not down, right actually. Okay, if I move all these one up, then it becomes what, 2 comma 1 and y becomes 3 comma 3. This is for up. If you see, the distance between this and this is not decreasing, the distance is same. Okay, so using some way, if I can actually identify this x and this x, I can say that the distance between these will always remain the same. Okay, I'm actually having difficulty in explaining this. Okay, basically like how do I explain this intuition? What I did was I actually marked all my elements as like any aij, I marked it as I comma like I plus n minus 1 minus j, and all the values which had a of like this values are common, they are all on the same diagonal. Okay, so basically if this is x and this is z, this x is 3 comma 1, which is actually 3 plus n minus 1 is like 4 minus 1 is 3, 3 minus 1 is what? Okay, so this is like 0 based indexing, 0 1 2 3 0 1 2 3. So my x is that 2 comma 0, so I will become 2 plus n minus 1 is 3 minus 0 is 3. Okay, and for this one I'll have what, I is 3, n minus 1 is 3 and j is 1, so 3 minus 1 is 2. So this is also 5 and this is also 5, which means that no matter I move these on the right side, on the left side, upwards or downwards, these two will always be on the same diagonal. Okay, similarly if you had an element here and here, okay, then it would have been like this would have been what, 1 plus, which is I plus n minus 1 is what, 3 minus of the column which is 1, and this would have been what, 2 plus 3 minus 2. So this is 3 and this is also 3. Which means that no matter how many operations I do on this one, up, down, right, left, these two elements will always be on the diagonal. Because if I make them on the right, it will be this and this. If I make them up, it will be this and this. If I make them left, it will be this and this. And if I move them down, it will be this and this. But the values of this, and this will always be 3. Okay. So what I need to do is for every ij, I need to find out this value. Okay. And whichever value of this is highest, I can say that I'll bring them on my diagonal. Okay. Since n minus 1 is constant, so can't we just omit it and write I minus j? We can do that, not an issue. Like this is the way I thought, but yeah, you are right. We can actually write I minus j as well. Now I'll show you my code as well. I'm not sure like how many of you are able to understand this. It's kind of little difficult to like make you understand. Okay, so basically what I'm actually doing is I have a map. Okay, and in this map, for every value that I scan, what I'm actually doing is map of I plus n minus 1 minus j. Okay, I'm counting this value. Okay, this value, so this is essentially n minus j only. This value I'm incrementing all v of ij. Whichever value in this index is highest, I'm taking that as the answer. Okay, so basically let's say I'm actually dividing all the diagonals. Okay, so what I am doing is this is my complete array. Okay, and let's look at this diagonal. Okay, value of this diagonal is I minus I plus n minus 1 j. Now if you see at this, or let's see I minus j only, which is better, I minus j, because if you see whenever you move this, I is also incremented, j is also incremented, so this value remains same. Similarly for this diagonal, if you move every column down and right, this value remains the same. Therefore all the elements in this diagonal will have some value, okay, which is actually like 0 only if we are assuming for I minus j. All the elements in this diagonal and some part of this diagonal will be present at what? Here. Okay, this diagonal will have its value as 1 because I is 1 here and j is 0 only. Similarly, all the elements of this diagonal will have I minus j equals to 2. So basically I'm dividing all my diagonals and finding in every diagonal how many ones do I have. Whichever diagonal has the maximum number of ones, I take that particular index. Okay, so let's say the value with 2 had what? Since this is 4, let's say like this is 4 into 4 matrix, and I can say that I had 3 ones at this 2th diagonal. If I had 3 ones, that means my total ones minus 3. Remove all these ones because they are not required, they have to be 0. Plus I needed 4 ones, but I only had 3. So essentially n minus count plus total minus count. This is the diagonal, the values required for diagonal, that I had count number of ones in the diagonal, but I needed n ones in the diagonal. So n minus count, and then I need to remove all the other ones. So total minus count. Is this clear to everyone? Okay, in my code I have actually written this MP also. This is not required. This line is also not required, and what? This is also not required. Because I actually thought that we need to make both the diagonals, so I made it for both, but we just need to assume for one diagonal only. Okay, I think we can move forward to problem F1 now. Okay, cool. Let's move on to problem F1. Okay, cool. Okay, what is this problem trying to say? That we'll call a non-empty string balance if it contains the same number of plus and minus signs. For example, this string has two pluses and two minus, therefore it is a balanced string. Now, we'll call a string promising if the string can be made balanced by several uses of the following operation. Replace two adjacent minus signs with one plus sign. So basically, plus minus minus plus, this is a balanced string because it has two pluses and two minuses. Okay, but one plus, now this string is not balanced, but it is promising. Okay, because we can actually take two adjacent minuses, make them one plus, and now the complete string has two minus and two plus, therefore this is a promising string. Okay, now we need to find how many non-empty substrings of the given S are promising. Okay, each non-empty promising substring must be contained in the answer as many times as it occurs in string S. Okay, cool. Okay, so let's take the very first example. Okay, the very first example is plus minus plus. If you see in this one, this is a balanced string because it has one plus and one minus. Similarly, this is also a balanced string because one minus and one plus. Therefore, the answer for this is 2. Let's look at the next test case, which is what? Minus plus minus minus minus. Now, if you see, this is a balance. Balanced string? Okay. This is also a balanced string. This is also a balanced string. Three minuses, because three minuses can actually be like two consecutive minus can be replaced with one plus, and then you'll have one minus and one plus. So this is also a balanced string, and this complete string also balanced because these two minuses can be converted to one plus, and it will have two plus and two minus. Therefore, the answer for this one is 4, and as you can see, we have 4. Okay, now how to do this? So F1 is pretty easy. What all you have to do is like write a brute force. So basically, if this is the complete string, take any two indexes. Let's say this is I, this is j, and for this particular array, just find out the count of ones and count of plus. Okay, let's say we had plus number of pluses and minus number of minuses. How do we see if this is a balanced string or not? Okay. If minus is equals to plus, then we can say this is a balanced string or promising string. Okay. If minus plus 3 is equals to plus, then also we can say it is a promising string because we have plus number of minuses here. Sorry, minus is equals to plus plus 3. Okay, because let's say this minus was 4 and plus was 1, which means we had minus 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 and 1 plus. Okay, we could have actually taken these two minuses and replaced them with 1 plus, and now we have 2 pluses and 2 minuses. So basically, all it needs are 3 minus. When you have 3 minus, it can be converted into plus minus. Take 2 minuses, convert them to plus 1 plus. Okay, so we know that if minus is equals to plus, then it is a promising string. If minus is equals to plus 3, then it is a promising string. If you see if minus is equals to plus 6, then also it is a promising string. Okay, because you'd actually split these 6 minuses into what? 2 plus and 2 minus, because in order to get these two pluses, you'll need 4 minuses. So 4 plus 2 is 6. Okay, is this clear? Okay, so if you see, basically minus plus mod 3 should be equal to 0. If this is equals to 0, then we can say that the given string is a balanced string or a promising string. Okay, so that is all you have to do. Basically, when you are in the complete string, let's say you are at this I and this j, just check if the count of minuses and count of plus minus minus plus percentage 3 is equals to 0. If this condition satisfied for this particular substring, then you can just add 1 to the answer. How to find count of minuses and count of plus? What you can do is you can actually make a prefix minus array and prefix plus array already. Okay, so I'll show my code also. F1 was easy, F2 is difficult. Okay, so for F1, if you see, what I'm actually doing is I'm first scanning the complete string. Where is it? Complete string is scanned here. Okay, then I have a variable as plus and minus, and I have count n plus 1 comma 2. Again, I'm doing everything one base indexing. Okay, so if s of I minus 1 is equals to plus, then I can just say that my plus is incremented. If it is equals to minus, then I can say my minus is incremented. I am storing count of I0 equals to plus and count of I1 is equals to minus. So basically this count is my prefix array. And so count to 0, the first row of count will have all the pluses and second row of count will have all the minuses. Okay. Then what I do is for every section of I and j, so I'm running I from 1 to n and j from I plus 1 till n. So basically this will cover all my sub arrays. Find out how many pluses I have in this sub array. So number of pluses in this sub array is actually going to be count of j0 minus count of I minus 1 comma 0. Yeah, okay. So, okay, it is column. Okay, so basically this is nothing but in the very first column for the jth row, see how many pluses do we have. So basically it will give me all the pluses we have till this index. Okay, sorry, you cannot see this. Okay. So if this is my complete array, this is I, this is j, count j0 will give me all the ones I had till this jth index. And count of I minus 1 0 will give me all the ones I had before I. So if I subtract these two values, I'll get all the ones I have in this section. Similarly, I do the same thing for zeros as well. And then I see if my minus is greater than equals to plus and minus minus plus percentage 3 is equals to 0. If that is the case, answer plus plus. That's it. That is all you have to do for F1. Why this works is because if you see in the constraint, it is given that the size of array is actually 10 to the power 3. And we are actually running a loop of n square here, so it becomes 10 to the power 6, which is okay. So that is all you had to do for F1. Now coming on to F2, if we look at F2 now, okay, if you look at F2, you will see that constraints are actually 10 to the power 5 now. How to solve this now? Now again, I'll jump back to my board. Okay, so let's say this is the complete string. And let's say I am at this ith index. And let's say my value of minus div, sorry, minus plus at this index, okay, is equals to what? 0. Which means that, okay, we can actually make this also. Minus minus plus plus minus minus plus plus. If you see, and let's say I'm at this index only. Count of my minuses is 4 and count of my plus is also 4, which means 0. That means this complete string is a promising string. But if you see, this difference is 0 at this index also. Because till this index, I had 2 plus and 2 minuses. Which means one difference was 0 here before the array, that I have nothing. Then it is, okay, so let's calculate only. Let's say we have an array. Array is minus minus plus plus minus minus plus plus. And let's find out the value of minus minus plus. Okay. So for this index, it is what? Minus 1. Oh, sorry, 1. Because we have 1 minus and 0 pluses. For this index, it is 2. For this index, it is plus because we have 2 minus and 1 plus. For this one, it is 0. For this, it is again 1, 2, 1 and 0. Okay. Now let's try to find out how many substrings subarrays can we take including this plus? It is actually going to be, okay, we need to have 1 0 here also for one base indexing. Okay, now because before this array there are no zeros and no pluses. Okay, so if you see minus minus plus here is 0, it was 0 here also. That means if we remove all the elements before this, okay, we had equal number of pluses and equal number of minuses. Similarly, we had a 0 here also. So if we remove all the elements before this, which are nothing, count of minus and count of plus in this string are same. Okay. Now, what if we had two minuses here also? So this is 3 and this is 0. Okay. If you see, this minus is 3, minus minus plus is equals to 3 here. How many subarrays do we have? Let's remove this one. How many subarrays do we have in which we can remove keep this minus included? One is this subarray. Okay, the other subarray. Okay, this is the only subarray we have here. Or the other subarray is this complete subarray. Which means when we had minus minus plus equals to 3, you had to count all the number of zeros you had before this. Okay. Similarly, let's say we had 3 more minuses here. Then this would have been 4, this would have been 5, this would have been 6. Okay. Now, if you see, how many subarrays can we make including this sixth index, this index? It is this subarray, it is this subarray, and it is complete subarray. The reason for this is because for this 6, we'll consider this 3, this 0, and this 0. Since minus minus plus, okay, let's write it m minus p. M minus p till this index is 6, and m minus p till this index is 3. That means in this total also we had m minus p as like percentage 3 was 0 only, or we can say like this was equals to 3. And since this was equals to 3, we can say that this is also a right subarray. So basically this 6 will have answers from this 3, this 0, and this 0. Similarly, let's try to count this for this 5. This 5 will say that if my m minus p here is 5, then if I have at any place m minus p equals to 2, which is at this index, then also I can say that I'll have a subarray after this. Okay. So essentially, what do we have to do? Again, like this is also a little difficult to understand in the first go. So if you have your m minus p equal to 6, this 6 will have the count of 3's you have before this, count of zeros you have before this, count of minus 3's you have before this, count of minus 6 you have before this, and so on. If your m minus p is equals to 5, then it will have how many 2's you had, how many minus 1's you had, how many minus 4's you had, how many what? Minus 7's you had. The reason is, let's say, okay, let's say this is let's say, okay, let's consider two indexes. Let's consider two indexes. At the ith index, m minus p is equals to 6, or let's take what, 4. And at the jth index, m minus p is equals to 1. So we can say that what, m of I minus p of I minus of m of j minus p of j is equals to 4 minus 1. Which means m of I minus m of j minus P of I minus P of j is equals to 3. This is nothing but count of minuses in the substring like j and I. Okay, so if this was the complete string and this was jth index, this was ith index, m of I minus m of j is nothing but count of minuses I have in this substring. And P of I minus P of j is count of pluses I have in this substring. And since this difference is equal to 3, I can say that this is a valid substring. Similarly, if m minus p was 1 and let's say m minus p for jth string was what? Minus 2. Then this would have been 4 minus of minus 2, which is 6. Again, since this difference is a multiple of 3, you can say that this string is a valid string. Okay, so that is all you had to do. Whenever you were going through the array, so if this was your complete array, and if m minus p at any certain point was 6, you had to count all the 3's you had before this, all the 0's you had before this, all the 1's you had, not 1, all the minus 3's you had before this, all the minus 6's you had before this, and so on. If your current m minus p was equals to 5, then you had to find all the 2's you had before this, all the 1's you had before this, all the 4's you had before this, all the minus 7's you had before. Similarly, if your m minus p was 4, then you had to find all the 1's you had before this, all the minus 2's you had before this, all the minus 5's you had before this, and so on. Okay. Now, and to find all this thing, you need a segment tree. Okay. So this is essentially everything that you had to do in this one. I don't know, like, if showing, like, I don't have my code. Okay, I can show someone else's code. Standings, and let's see Rainbow's code. I don't know, like, how many of you will be able to understand this one, but like this is essentially what this person is doing. So what he did was made the complete scanned the complete string. Okay, after that he made a segment tree. Okay, and of size 2 times n plus 1. And in that, okay, so I don't really know like how to explain this to everyone. So he made the size of segment tree as 2 times n plus 1 because what is the maximum value of m minus p? Maximum value of m minus p will be n. Minimum value of m minus p will be minus n. And total number of values between minus and n are actually 2 times n plus 1. Therefore, you need a tree of size 2 times n plus 1. And then for every index, do the same thing. Like if this difference, like a of I minus r percentage 3 is equals to 0, okay, then you just have to query for n plus a of I. Why you are doing n plus a of I is because a of I is actually nothing but the difference that you're taking. You're adding n to it. You're adding n to it so that your n becomes 2n, minus n becomes 0. So this array of 2n plus 1 becomes from 0 to 2n only. So if you have a difference of minus n, it will be at 0th index. If you have a difference of n, it will be at 2n index. And that's all you had to do. A little difficult to understand again. So like if you are someone with the rating 1600, like 1500, 1600, it's okay if you don't understand anything. Okay, cool. Okay, so I think I can end the stream with this. We solved all the problems today in the stream. Okay, cool. Do like the stream if you think this helped you in any way, and also subscribe to the channel if you want more such